All right. So welcome back. Well, welcome back to me. I guess you guys have been here all along. I sure appreciate you guys meeting and working together. I hope that last week it was productive for you and wasn't a complete waste of time as I was out. I appreciate you guys understanding, we're all in this together. I was having more fun than you. I'm sorry. We had a great time in Florida. There were no crowds. It was beautiful weather. But now we're ready to get back down to business. So today, I want to spend today focusing on GEE, going over homework 8 and 9 and wrapping up some loose ends with GEE. But before we even get into that, I want to talk course projects and scheduling. So anyone else have anything to bring up while I bring up the schedule? I'm going to have to shrink you guys because I am now teaching from home, not from campus. They've really suggested that we stay off campus if possible. And so I only have one screen, which makes it's really difficult to keep all your pictures up and still see anything else on my computer screen because I have a small laptop, which I love. It's a Surface Pro, a Microsoft Surface Pro. They're phenomenal, but it makes it a little hard to see everyone. Okay, so let's see. Wow, we are all the way on November 10th. Look how far we are, guys. So we should be finishing up the GEEs today. GEEs. And then this is all we have. We basically, after today, we have 2 weeks of discussing generalized linear mixed effects model, and then Thanksgiving break, and then come back and do power and missing data and some of those other, topics to finish up the course. So course projects wise, these are the dates that I really wanted to talk to you guys about. You're supposed to, it's been on the calendar that you exchange your draft of your course project with a peer when? Thursday in 2 days. Who feels ready to do that? Julie, no. Maybe a little bit. Yeah. So I am open to changing that. So the reason that I had set it at that date was that you would have a week to look at somebody else's project, and then a week to incorporate any changes that were given to you. It's not for my benefit, it was your benefit. I really want you to be able to have that chance to review someone else's and then incorporate changes back on yours before you give your presentation. So right now we have the presentation set for December 8th and 10th, and then having you turn in the actual paper on the 15th. Does anyone want to propose a change to that schedule? I don't want to force it down anyone's throats. What would be more realistic?
Can we just push it back a week for the, because if we turn them into our person, our peer by the 19th and get it back by the 20th, the 26th is Thanksgiving, isn't it?
Yeah.
Well, what if we just got it back before Thanksgiving to them? Because it's not like we turn it in class, at class time.
Yeah, and I can change the Canvas dates. And I'm okay if you and the person that you're swapping with, whatever round robin partner swap that you're doing, as long as you okay it with them, so I would say I'm totally cool with marking the Canvas date to the 19th, but if the person you're swapping with is okay with pushing it even to the 20th or such, but I just really want to make sure that you have adequate time with everything else that's going in your life, that this is a meaningful experience for you and helpful. Yeah, and so have them back about Thanksgiving. That still gives you the first week in December. Maybe have them return by December 1st. And then that gives you that week before the presentations to do, the final incorporations. So Julie, you're giving it a thumbs up. So as long as we get them returned by December 1st. Okay. Anyone else have any more feedback about that? Everybody's is so different. We all got different complicated issues coming up. Mike?
Yeah, when do you want our feedback posted then? I mean,
You're not going to post to put it onto Canvas. I would say, when do we want to have that? So I would say December 1st. So in Canvas, let me go back to the Canvas dates. So here we go. Let's see. Right now, so the exchanging drafts, right now it says the 12th. Let's edit that. Let's put this exchanging drafts. What do we say? The 19th, push that out another week. And then let me save this change. And then uploading your review, your feedback, push this out to, here it is. Return the draft, put in the feedback. Let's move this to December 1st. I don't want this to kill anyone. That's like not the purpose at all.
So I'm
exercise, yeah.
I'm a little confused. So what we're saying is the 19th is the day that we need to have it submitted to our person.
And December 1st is when you need to give it back and upload your review.
Okay.
Feedback to the persons you read, your peer review.
Got it. Okay.
That work? So about the 19th, at least fill this out by the 19th. If your person is okay giving you an extra day or two because they can have time in their schedule to look, they aren't going to look at it till the 22nd or something, then that's fine. Just fill out who you're giving it to. But by December 1st, have given the feedback back to the person and uploaded that feedback into Canvas.
Got it. Thank you.
Okay. So for the course presentation, just a few slides. So we have the things, the bullet points that are on the rubric. Those are the things you need to have slides. So just a little tiny bit of background, basic descriptives, raw data plots, what models you did, what worked, what didn't work, your results in a table and then a figure. And then kind of like the general story and what you learned from the process. Some of you are comparing like an MLM to a GLM. Some of you are comparing a GEE to an MLM. Some of you are comparing an ANOVA to an MLM. That's not required. That's useful learning, but incorporate that however it's working for you in your specific situation. And again, if you're not sure about anything, I'm back. I can make appointments in the evening, the weekend, whatever it takes to get that handled. So if you're stuck on anything from importing your data to wrangling your data wide to long, long to wide, please let me know so we can not be hung up on those things. Those are things that I want you to have some experience with the complexities, but I don't want to kill anyone off on being so confused and spending hours on those things. Okay. So there's course projects. Now homeworks, GEE. So, let's look at the discussions. We've got 3 discussions that are open right now on Canvas. One is about generic information background reading about GEEs, the theory and the application, and then there's homework 8 and 9. So those 3 things are going on. So right now, the background, GE theory and application, that's due on the 12th, as well as homework 9, 12th. Homework 5 was supposed to be done by the 10th, but I haven't closed it. I kept it open because I was gone, so you can continue to make comments on that one. So I want to, I wrote down, I took some notes about the things that were like problems, issues, things you want to discuss based on the discussion board. So in general, GEE, we have the 2 packages to fit GEE models. We have GEE package functioning GEE, and then we have the GEE package with the GEE GLM command. So by and large, those 2 package functions will give you the same results, but there are differences between them. Mostly the differences are small nuances in how the data or how the output is packaged. So the GEE function package, it does really good with tech reg. It plays nice with the tech reg. So that's why I usually have you fit it first, because it plays really nice with tech reg. The GEE GLM from GEE package, it used to not do anything with the tech reg. Now they made some changes. A GEE GLM function model can be put in the tech reg, but only if it's autoregressive or exchangeable. So someone had, I can't even remember who, it's all running together, said they had an unstructured or an independent model that would fit with the GEE GLM, that they couldn't make a tech reg package out. And that's because it just doesn't work. So if you try to put lots of more than one GEE GLM model in a tech reg, it will send you an error if any one of those models is not autoregressive exchangeable. So some people were trying to make a tech reg table with all 4 models, autoregressive, exchangeable, independent, and unstructured, all 4 of them, and it's going to croak. There's no way to make that work. The only way to put all 4 types of models is to use the GEE way to solve it. But that has the problem that it often fails with autoregressive 1 if at least one person only has 1 observation. So the 2 functions have these slight nuances about them, and that's why on both assignments and on always in the encyclopedia and in class, I usually fit the models with both packages, because if you want a table, you need to use the GEE function, but if you want to plot it, you need the GEE GLM version. So those are kind of the nuances that I found worth working with them. Now the QIC, that only works with the GEE GLM. So if you're comparing models, you want to use the GEE GLM as well. Now there is, with the QIC measurement for comparing models, if you're comparing the same predictors but different correlation structures, you need to make sure you do type R equals false. If you're doing the same correlation structure but different predictors, you need type R equals true. So that is another kind of nuance about using the QIC command. And we're going to look at the homeworks. We're going to go over both of them today to see this in action. A lot of people said, I need help, especially on homework 8, with the interpretation, especially with the 3-way interaction. So we'll talk about that and how you would actually write that up. And the plot is so instrumental in that. So interaction parameters. And then one other thing was noted is the waves command. So in the GEE GLM function, you can use the waves equal time or week or whatever. And Carly, I think you were the one that said when you tried to do the unstructured, it crashed your R every time. And it's when you use waves. And so I'm going to show you that.
Gotcha.
We can go over that. And then homework 9. What was the biggest with homework 9? What made you most uncomfortable with homework 9?
Well, nothing was significant.
Nothing ends up being significant. And you might be uncomfortable with that, but that's what you should have gotten to happen. So in homework 8, you end up with this complex 3-way interaction, but homework 9, nothing significant. And it's just, you're going to run into both types of situations. So sometimes we build a model, we expect something, sometimes we get what we expect, and sometimes we don't. So homework 8 and 9 are supposed to have both extremes going on in them on purpose. But we will look at those. So let's go to homework 8 first, shall we? So the problem with using the waves command and crashing R, all of these things come down to, they're all symptoms or issues that are fundamentally happening because of missing data. So because of those comments today, I was trying to come up with a nice way to show you. Yeah. Does someone have a question? No, it just started giving me feedback. So here's homework 8. I went in, oh wait, there's homework 8. I went in and looking more at this data set, I put together this plot. This is I use the NIAR package, that missing, to look at missing data patterns in this data set. So this is the one where we had illness severity, the IMP 79, at 4 time points: week 0, which was baseline, 1, 3, and 6. So unequally spaced, but structured the same for every person. And this is what I found, is that there's all different patterns of missing this. So the most common is people who miss the last time point. There's what, how many? 53 people that missed the last time point, which, you know, that seems reasonable. But there is also, oh, why did that go small? I'm having a hard time trying to get all these windows to see your faces. Why didn't I get it? It's not going to run it, I bet, because I didn't run all that's above. I'll try that again. Is it running? Yeah, here it comes. There's also different patterns where people skipped an intermediate visit and then continued. So the most common are 53 people in our sample missed just the last time point. The second most common skip pattern is there are 45 people that did the first 2 and missed the second 2. But there are 13 people that only skipped week 3, and there's 5 people that only skipped week 1, and there's 3 people that don't have baseline, and then there's 3 people that only have baseline. So the problem that this happens with a GEE model specifically is it's modeling the correlation matrix. So here we have 4 time points: baseline, 1 week later, 3 weeks later, and 6 weeks later. So that's a 4x4 matrix. So they're sequenced 1 through 4, but what happens if someone misses the middle one? Should we count them as 1, 2, 3, or should they be 1, 3, 4? And so this is where the waves function in the waves option in the GEE GLM function comes in, is for reiterating where the missing one is and how to handle missing data. So we come down here. So here's our correlation matrix. So this is set out to use pairwise complete. But what happens if someone only has the first and last visit? Should they be counted as 1 and 2 or 1 and 4 for the correlation matrix? And so when you fit the GEE function, it's assuming that you have all 4 for every person. And that if you have less than 4, it's still 1, 2, 3, and then the last one's missing, or 1, 2, and the last 2 are missing. So where we have like intermediate visits missing can be problematic. And I don't think in this case it made a difference. But what I had to go is the long data in your homework assignment. If someone was missing a visit, it was just not in the data set. But I had to go back for completeness, and I can send you an updated version of this, is I took the wide format and then restructured it to long. And when I did that is what you get empty rows for the missing data. So if I show you here, so this is, see the first few people, like here we have the first person is 1103. They have all 4 time points at week 0, 1, 3, 6. They have all 4 time points. But what if we keep going down here? Oh, there was one. Where's another one? Let's get another one. So here's one. Here is this is a great one. 1118. That person, they have the first 2, but the second 2 are missing. This is an okay skip pattern. This is what the data assumes. But look at, or the GEE function assumes, but look at 1119. They're missing the first visit. Now in the data set you were using, data long in homework 8, These lines that had missing IMPS, those lines were just out of the data set. So I had to go in and recreate the data set, and I just did this in the last couple hours to leave those empty observations in the data set so that everybody has all 4 lines, whether or not they had the outcome measured or not. And this is, the descriptives would be the same, but what this does is it informs the model if there's a visit missing for someone, which visit it's missing, because they're all sorted the same. So that kind of threw it kind of a hitch. It doesn't, the results end up being pretty darn identical either way. So in the, when you do in homework 8, the GEE models, these models all have the same predictors. All of these models have the same 3-way interaction between sex, time, and group. These differ according to the correlation structure, not the predictors. And in this one, autoregressive fails because for GEE, it cannot handle having a person with only 1 observation. It just can't do it. They're in the GEE pack, GEE GLM, it has a workaround, but this one doesn't. So here, the GEE models, we can put them all in a tech reg table, but we can't put in the autoregressive one because it failed to fit. Now, when we go back and fit these models with GEE pack, GEE GLM, the autoregressive will fit, even though we have people with 1 observation, because this package has a workaround built in it, which I can't even explain to you. I don't know how they do it because I've never read it. I just trust that it's true. So usually we put in the encyclopedia and in the class example, we put in this option waves equals time or week or observation or something to show the sequence within a person, which sequence they should be. If you're using the data set that has the blank observations in it, you do not need this. And so whether or not you have that in there, the model will fit the same. Now, when we go, I went over here into my help menu and type GEE pack, GEE GLM to get the help page up. I was reading along in here, trying to figure out, to teach you the best way about this. Here it says waves, and it says it's a variable. I think they mean variable. There's a typo there. So variable specifying the ordering of the repeated measurements on the same unit. It's also used in conjunction. This is specifically important if you have missing values, and it says to consult the vignette, which I actually didn't do. But it's interesting that if you come down here, it says warning, using unstructured correlation structure only with great care. It might cause R to crash. So Carly, when you put the waves command in, I'm assuming you used the waves command, and then when you did unstructured, it just killed R.
Yep. I missed that note you had about not including the wave in it. Yeah, I just restarted my session. So
yeah. So, and you had to, and there's no way to get around it. I don't know exactly why it's doing it, just that that's a known issue. So when you do the unstructured, you need to not include the waves in there. Now, technically, you should have either the waves in there, waves equals time, or you should have your data set so that it has missing lines. So everybody has line 1, 2, 3, 4, even if some of them are missing, and having the outcome be NA on those missing ones. Okay. So again, this is only an issue because we have these various missing patterns, which usually a homework assignment wouldn't show you, but I will tell you in real life how common is missing data. It is more common than it is uncommon. It is very common. Okay, so now these GEE GLM models, using this package is beneficial because we can make plots and we can do the QIC and we can fit autoregressive. but using this package is problematic because we only can do a table for exchangeable and autoregressive. We cannot put the independent or auto unstructured in a TechReg table. It just doesn't work with TechReg. And it has to do with the goodness of fit variables, and maybe someday I'll see if I can make a workaround for it, but right now you just can't. Now the good news is, how often are we going to use an independent structure? Usually never. We only use that as like a baseline comparison model because it's basically saying the repeated measurements are not correlated. Well, then why are we doing GEE if they're not correlated, you know? Unstructured, it can be problematic because you can't put the GEE pack, GEE, GLM unstructured model in a TechReg package. So my only information for you is to use GEE package if you really are going to use an unstructured correlation matrix. Okay, so did we have convergence issues with GEE? Yes, because for autoregressive, we have at least one person with only one observations. But when we move to GEE pack, the GEE GLM function, do we have convergence issues? Not really, no. We might have crashing of R in the unstructured if we try to use waves, but it's not a convergence issue. Okay, so here's the QIC measures to compare. Now, this is one thing that came up is when you're doing QIC, these models have the same predictors, but different correlation structures. So you have to say type R equals true. If you don't type R, anything in there, the default is type R equals false. And that's not the right one. If you do that, I think autoregressive and unstructured come out with the identical QIC values. So at least one person noted that in their discussion board. So make sure if you're comparing models that differ in the correlation structure, but not the predictors, use type R equals true. So which becomes our best model at this point, including the three-way interaction? What do we want QIC to be?
Autoregressive.
We want it smallest, so that's autoregressive. Now, how much better is autoregressive versus exchangeable and independent? Just a tiny bit, but we'll go with it. So, okay. So here's the interaction plot. Now, to interpret this, we got three-way interaction here. The good news is our three-way interaction involves categorical variables. Sex has 2 levels, group has 2 levels. That's your friend. It's your friend when you have those categorical variables. So of the 3 variables, sex and group are binary. Time is continuous or has 4 levels at least. So it makes it a little easier to talk about. So the way I would write this interpretation is to talk about your reference groups first. Now, we are lucky in this one because the autoregressive, we can't, from the GEE GLM, we can put in a TechReg package. So I made the table. Again, you can put multiple models in here, but only if they are autoregressive and exchangeable. Oh, I didn't run all of them, so that's why it's. So I could put those 2 models, autoregressive and exchangeable, in a table. Oh, why did I put an extra E there? Spelling. So you can put these 2, but if I try to put GEE, GLM, if I try to put the unstructured in here, it will say no dice. So that was, Joey, I think you talked, was it you that talked about that on the discussion board? Yeah, so we can put the autoregressive, which is our one to go. So if we look at here, for sex, what's our reference category?
Female?
Female, because it's not the one listed. For group, what's our reference category? For group, the reference would then be?
Placebo.
Placebo. So female placebo. So here it would be the female panel, placebo is the blue dashed line. So for the blue dashed line, this is the slope for time. So for the female placebo group, the slope is negative 0.27. So we're going down 0.27 each time. So here's this blue line. So its slope is negative 0.27. So it's starting here and it goes down negative 0.27 every time we go over one time point. Now, people had, when we have a three-way interaction, what should we interpret first? Somebody said main effects, then two ways, then three ways is what they've seen. And I have seen that a lot, and it is wrong. No matter what model you're doing, if you have an interaction in it, you always interpret the most complex interaction first. Always, always, always. So the first one we should interpret is this three-way interaction. So you should say first, using the autoregressive correlation structure, there is a three-way interaction between sex and group and time. Another way to say this is sex moderates group differences in change over time. So in interaction, we can use the word moderation. So that's always good to say that first. So I'd say, using autoregressive correlation in a GEE model, we found that sex moderates, let me type in front of you, that's always fun, moderates group differences in progression over time. And that's the three-way interaction. So we can put our beta with a standard error and its p-value, which we don't have the exact p-value here. To get the exact p-value, TextReg package doesn't give it to you. You have to say summary of the model. That'll give you the actual p-value. So we can see that the p-value, this first is actually 0.021. So yes, we have this three-way interaction. From there, it's helpful to look at the plot to be able to talk about it. Now, I said reference categories first. So I would say for females in the placebo group, females in the placebo group decrease. And again, I'm typing, and I'm not a good typer anyway, decreased a little over a quarter point each time interval. Beta equals 0.27, standard error equals what? Oh, and it's negative. Standard error equals what? 0.7, and the p-value is less than 0.001. So it's good to get a reference going.
Can I ask you a quick question?
Yeah.
Could you say something about why we should always start with the most complicated
interaction first? Mm-hmm. Yeah. So we all know, or hopefully at this point, you've been drilled that your independent variables should be independent with each other. That's why they're called independent variables. If your predictors are not independent, if you have predictors that are correlated, if your X variables are correlated with each other, we have multicollinearity. And what do you guys, have you been drilled about multicollinearity? What happens with a regression model when your predictors are correlated? You have weird things that happen in the interpretation. The predictions might be fine, but the interpretations can be wonky because the p-values, the significance can get split between the two alternating ways by simple changes in the data. So when we do an interaction, so let's just think about a two-way interaction. If I have variable 1 and variable 2 in their interaction, the interaction is always correlated with the main effects. Usually we don't call this multicollinearity because it's not the variables have natural multicollinearity, it's structural multicollinearity. An interaction is always correlated with the main effects. And that is why we should never interpret those main effects if their interaction between the variables are also in the model. Shaking your head, Mike. Anyone else? Does that make any sense? So that is part of the reason. Now also let's talk about what does an interaction mean? An interaction means the effect of this variable depends on what happening with the other variable. So when we interpret the main effects, and this works for ANOVA, regression, single level, multiple linear regression, multi-level modeling, GEEs, every regression-based model or t-test or anything. Well, not a t-test because you don't have interactions. Anytime you have an interaction, interpreting the main effect is going to be collapsing across the other variable. And so the interaction says these effects depend on each other. The effect of one of these things depends on the other. So should we interpret them one at a time? No, the fact that there's interaction says you have to interpret them together. So if we have a three-way interaction and we look at the main effect for one of the variables, that's collapsing across the other two. And the three-way interaction says you shouldn't do that because the effect of any one of those depends on what is going on with the other two. So fundamentally, if you have an interaction, the main effects don't have the same meaning as they do in a non-interaction model. Then technically you have the structural multicollinearity between the interactions and lower level main effects. And that is why you should always look at the highest level interaction first instead of starting with the main effects. Now, when I teach 6600, let's see, I've got that textbook here. Anyone use this behemoth textbook? Barry Cohen's Explaining Psychological Statistics. He sometimes tells you to look at main effects before the interaction. And I disagree heartily, along with every other statistician. Now, if you have an interaction that's what we call ordinal and the gap just grows, it's not so bad. But if you have a crossing interaction, if you have one group does this, one group does this, what if you collapse across groups? You might see no effect. And this is why sometimes here we have a significant interaction, and after accounting for the significant interaction, does male have an effect? Does sex have an effect? There is no main effect because sex is only involved in the interaction. So if we look at this picture, does sex have an effect? Yes, it definitely, sex makes a difference, but there is no main effect because sex has a moderating effect. So if you were to look at the main effects first, you would start off saying sex has no main effect. But if we look at this picture, it's very clear that sex does have an effect. But the p-value for the main effect is not significant because the significance of gender is tied up 100% in the interaction. Okay, so this is a concept that applies to every regression model or every interaction moderation model out there. And it's something I don't think we drill quite enough. So when you interpret this, you must start with the highest level, most complex interaction. And we say, yes, there is a moderating effect. But then when it comes to the hard part is how you interpret this in a smooth way. And the picture can help. And then going back to start with if you have categorical variables, look at the reference category for all of them. So reference category for sex is female, for group is placebo. So we can say what the slope is for that total reference group, females. So we'd start there. And then we'd say, so that's we did this blue dashed line in the female pattern. It has this going down 1/4 of a point every interval. And then now we can start saying, well, that's for females in the placebo group. What about females on the drug? And that would be this main effect. So is that significant? Heck yeah. This is telling us that the drug for the main effects, we interpret it when all the other predictors, so the way we interpret a beta is holding all the other variables constant. So if we hold sex at female and time and the effective time, so it would be a little bit more complicated than that. You can do a simple slopes analysis, but usually it's good enough to reference the plot as seen, as shown in figure below, whatever figure X, we'll call it figure X, in the placebo group, or in the, for females, let's start with the panel. For females, the drug group decreases at a much higher pace or much higher speed, or it decreases more over time. The same similarly for males, now we could move to the other panel. Similarly for males, the drug does have result in greater decreases over time, but the effect is not as strong as it is for females. Now, how you actually come up with that wording, I mean, I have to look at this plot and look at this plot and look at the plot over and over again to kind of make it read like English instead of like math. The key for the interpretation is reading like, how would you what would you tell your grandma about this? You know, grandma, the drug has an effect. You could even say the drug does have an effect over time, with decreasing illness severity over time. The effect seems to be stronger. We see a greater decrease for females than male. Open it up. What do you guys think?
Well, one comment is that I actually switched them on my plot. I switched group and sex, and that helped me, I think.
Yeah. So that's another. When you have a three-way interaction, which one is moderator 1? Which one's moderator 2? There's more than one way to do it. And sometimes, okay, so we can see in placebo, there's not that much difference. In group, there's not much difference.
Well, this one helped me see why the females, why the gender became flattened, right? Like that, why it was no longer significant, because in one, the females are completely above the orange, and in the other, the females surpass the orange. And that's why when you don't consider the groups and the time, it's like collapsing, and now it's not significant, like you were saying a second ago.
So on placebo, even on placebo, the men are doing better than the women.
Exactly.
And so when you give them the drug, it's like the women catch up and surpass the males.
Right.
Yeah.
Which is why the coefficient's no longer significant if you don't consider the group changes. So anyway, that's a thing that helped me understand, I think.
Yeah. And this plot is just as accurate as the other one. Now, I like this one better because for me, sex is probably stable and people are not going to be by and large changing their sex, but we can easily alter whether they're taking the drug or the placebo. So it's easier our main purpose in doing this study is to see, does this drug differ from placebo? So that's the main comparison. So I want to compare a line for placebo and a line for drug. And so that's why I chose to panel it this way. But paneling it this way is just as accurate. And doing it both ways can help you wrap your mind around it.
Exactly.
Yeah. Ariel, did you have something to add?
No, sorry. I thought it was helpful to hear you both explain that. So thank you.
Yeah, there is there's no recipe card for these interpretations. The more you do, the better you get at it. And the more you sit with these pictures, the more you can digest it and then regurgitate it for somebody else. And it's a very important skill or thing to develop, is looking at a picture and being able to regurgitate what's the important point about the figures. Yeah, so this is one where doing simple slopes might be helpful. I don't know if there's a package to do simple slopes for GEEs though. Yeah, Joey?
I was just gonna say, this was a challenging part when I was doing this on my own, and this discussion helped. Would you have a problem with like tidying up this on my old assignment, like resubmitting?
Totally. I have not started grading this assignment. Anyone who wants to resubmit it, I will only ever see the last one that you submitted. So even if you've turned it in, if you want to, like Joey said, tidy it up and rewrite something or readjust anything and re-upload it, then I will grade your most recent submission.
Okay, thanks.
Especially because I was not here.
Do we need to?
You don't have to, no.
I mean, are we going to lose points if we don't have the interpretation correct?
If you're dead wrong, you might lose a couple points. If it's just a little less smooth, no.
Okay.
But I will give you feedback on whatever you have last submitted.
Okay. I also am a little still confused because, like, so that clarifies what we just talked about, clarifies why the gender is the way it is.
Mm-hmm.
The way you started was by interpreting the 0.27.
Mm-hmm. And that's called a simple slope. So that would be the slope for what. So often we look at this picture and we're comparing the slope, because here we really want to know about change over time. The whole point of this is everyone's starting out about the sign, but who changes the most? And here we want to see them going down, because we want in illness severity decreasing. So what makes them go down fastest?
So my question is, you interpret it as 0.27 being the slope on the left for the placebo group, right?
For the blue dotted line.
Wouldn't it?
Females.
But I was confused because I was thinking it would be the slope not considering, like, holding group constant, like the overall slope of.
Yeah, let me
of over time, like not considering group and not considering gender.
Yeah, so let me do this. Let me write on this. Ooh. There we go. That's a better one. Okay. I want to make you guys go away. I like looking into your eyes. I
feel bad that I'm taking up.
No, you are asking, I'm sure, what a lot of people in class are thinking. Okay, so these are our betas. So let's write the equation. So it would be Y, which is the illness severity, IMPS, is equal to our intercept 5.66 plus 0.02 if you're male, because that's males, minus 0.27 as time increases, and then drug plus 0.62 if you're taking the drug. And this drug, this is either yes or 1 equals yes, 0 equals no. For male, you'd plug in a 1 if they're male and a 0 if they're female. And time goes 1, 2, 3, 4, right? And that, if we only had main effects, we'd stop there. But then we have all these other things. So let me see, let me erase this. I'm gonna have to shortcut this because I'm gonna run out of room really, really, really fast. So I'm gonna just use the first letter of each variable so that I can get this to fit in. So 0.2 if you're male, minus 0.27 for every time. So I'm just use T, plus 0.62 if you're taking the drug. I'm just gonna put a D. So we've got M T, and D. Those are our variables. Minus 0.11, and this is male times time, and minus 0.31, and this is male taking the drug, and then minus 0.61, and this is for time taking the drug, and this last one is plus 0.28, and this is male drug time. It's a lovely equation, right? So what I'm doing is sometimes called simple slopes analysis. And again, this works for all regression models that have an interaction, whether you have multiple linear regression, multi-level modeling, GEE, or generalized linear mixed effects model. So usually the easiest way to do simple slopes. So all of these betas are holding the other ones constant. And we have categorical variables, or the intercept. What is this intercept? 5.600. That's if we plug in 0 for everything. So that would be, what does, for the sex variable, how do we make that 0? That's if they're a female. So a female taking the placebo at time 0 would have a illness severity of 5.66. If we look at that plot, where does it start? Now, I guess it would be at time 0. Our time goes 1. This is why we'd want to center time, so it starts at 0. Because if we go back to time equals 0, it would cross at 5.66. Okay, so let me see. Let's go back to that picture. Okay, so let's concentrate on the slope for time, change over time going down. So let's start with the female. So that's male equals 0, and the placebo, which is drug, equals 0. So this is all reference categories. So that means we're going to plug 0 in for male and 0 in for the drug group. So if we put that into this mathematical equation up here algebraically, we have IMPS is going to equal 5.66. Now, what's going to happen with this first parameter? It's going to be negative 0.02 times 0. What do we get when we times something by 0? Nothing. So this first term would be 0, and then we'd have minus 0.27t. And then if we're in the placebo group, then drug is 0. So we plug in 0 for drug, and then this 0.62 times 0 is 0. Now let's move over here. If they're a male, or if we're talking about female, then we plug in a 0 here. And it doesn't matter what else is there. If we timesing by 0, what happens? It goes away. So if we're talking about a female in the placebo group, this parameter goes away. This parameter goes away. Sex is female, that goes away. Sex is female, that goes away. Placebo group, that goes away. Sex is female. What are we left with? So this is the equation of the female, for the females taking the placebo. So the slope ends up being the easiest to calculate for all reference groups, if you're referenced for all the categorical variables. So the female placebo group would start at 5.66 at time 0, which doesn't make any sense here, and it's going to go down 0.27 each time point. So this is our simple slope, or our slope for the female placebo groups. Now, let's see. It's going to be the easiest. Let's do this for the other line in that plot. So the other line was still in female, but now it's female taking the drug. So they're female, so that one goes away. They're a female, so that one goes away. They're a female, so that one is times 0. They're a female, so that one's times 0. So what are we left with? We'd have IMPS equals 5.66 minus 0.27 T plus 0.62 because they're in the drug group. So drug would be 1 minus 0.61 time because drug, this would be 1. Drug would be a 1. So what happens to the intercept? The intercept is a little bit higher. What do we get when we add that? 5.66 plus 0.62, 6.28. So it has a slightly higher intercept. And then what happens to slope? Instead of going down just a 1/4 point, now the slope is going down an additional 0.61. So it's going down 0.88. So the slope for females, the slope in placebo is 0.27, but the slope in the drug is 0.88, going down negative 0.88.
So I think that based on what you're saying here, that what I said earlier isn't accurate, because I was thinking that the fact that sex female is 0.02 would mean that like it's telling us overall
males are slightly higher. So this let's see. So this one right here, this 0.02 is telling us that collapse across all time and both drug and placebo group, men are 0.02 higher.
Is that, so that's for time 0 and drug 0, right?
No, it's collapsing across all times and all drug and placebo, which is really a meaningless thing. Why would we care?
Kind of a
Carter?
I think I'm curious when you were talking before about main effects, and now I'm wondering, so if you're interpreting this model, could you still say with these coefficients, the main effect of sex is the main effect of time is, but you just clarify that it's part of the complete.
And that's what people do, but I think that it's misrepresenting it, because you would say males are not significantly collapsing across all times and both drug and placebo, men and women are not different. But why would we want to know that?
Isn't that kind of a mean of a means? It's meaningless.
Yeah, it's a mean of a mean. Yeah. It's meaningless. So averaged across all time for both the drug and placebo group, there's no sex difference. Well, okay. So what? I mean, where's R? No, that's SPSS. I don't want that R. So if we collapsed each of these lines and made them flat, and then collapsed the 2 panels, so we only end up with 2 lines, flat lines, they would be basically the same. Okay, but I want to know if the drug helps people decrease over time. The research question, the reason we did this was not, are men and women different? End of statement. We want to know, do men and women decrease differently across time? Where are we at time? Holy cow, we need a break. Let's take a 5-minute break and come back and wrap up homework 9. I think homework 9 will go slightly faster than homework 8.
Sarah, can I ask you a question? Can I actually, since we moved back the date of peer review, can I actually move back my meeting with you so that I have more time to look over it? Before I was like trying to rush and get it in, but if I have an extra, like I feel like we could, like it would be better for me to have more time to prep. So do you have anything on Friday or Monday?
I do. I have Friday and Monday both. Which time did we have you down for?
We had tomorrow at 6:30.
Okay. So let's.
Sorry.
Friday, I could do 2 o'clock. Or Monday, I could do. I got 10 o'clock meeting. I could do 5 or later.
Can we do 5 on Monday?
Yeah, let's do that. Okay.
Okay. Thank you.
Yeah.
Yeah, I just feel like it'll be more productive if I have more time to prep.
So Monday the 16th at 5 o'clock. There we go. Okay.
Thank you.
Yeah, not a problem. Oh, stop the recording. All right. Let us turn our attention to homework 9. Fabulous homework 9. So homework 9 has to do with a yes or no binary outcome. So we're doing logistic GEE. That's the difference here. And here I went through and I added in to my key, and I'll add it into the homework assignment for next time. I'll look at the missing data. Now, what do you notice about the missing data for this data set versus the last data set?
The points they're all linked or adjacent.
Yeah, so it's like once they became missing, they were always missing. We don't have this pattern of yeah, they have the data, they're missing, and then they're back again, and then they're missing. We don't have any of that going on. So everyone has the first 4 time points, because there's 8 time points here. Everybody has the first 4. And after that, once they miss one, they miss the rest of them. So that's what's different about this one. So for this case, having the waves or worrying about missing data is not nearly as important, because the data they have is always sequential and the data that's missing is always sequential. We don't have this popping back in and out issue. Just wanted to note that before we went forward. Okay, so when we go in this nice curve, lovely curves, fitting these models. So here's our correlation structure. Based on this picture, what do you guys think? Does this look autoregressive where we have decay over time? Does it look exchangeable where all of the correlations are essentially the same? It's not clearly one or the other, that's for sure. Now, anything jump out at you when you look at this correlation matrix?
The center. I mean, the center is kind of very, very lightly correlated. That's what I thought.
Yeah. If you were just to look at the first 4 observations, we have some of this decay. But what happens if you look at the last 4 observations? Anyone see this correlation of 1 and be like, wow? And I think this has to do, and this is very commonly seen, is we have a great deal of attrition. So how many of these, what happens to our sample size over time?
Gets a lot smaller.
It gets a lot smaller. And here's our sample. So our sample size, let's see, is this, well, that's proportion. Our overall sample size. Where's that missing thing? Yeah. So we have this attrition over time. And so what happens, and what we also have the issue that what happens with the chance of having this outcome. Over time, the chance goes down. So when you have a shrinking sample over time and the chance of something happening going down, when we get out here to the last 2 time points, of the babies that are still left in there, none of them get it. So it's like our correlation gets really, really strong because we have less variability. They're just, the event's not happening way out to the 7th and 8th time point. If they were going to have this wasting disorder, it's more likely to happen in the first 4 months. When you get out to 7 or 8 months, it's not going to happen at this point. So that's, correlations of 1 are almost never seen. So yeah, so here, once we get past a certain point, it just doesn't happen. Okay. So fitting these models. So first I had you fit with exchangeable. Did I have you? Yeah, so this is 2A, fit the full model with the 3-way interaction plus a main effect for centered birth weight in 100-gram units with exchangeable. And then make a table. Now, what do we see about the 3-way interaction? Not going on, no. So the next thing you're supposed to do is fit more and more reduced models by, what did it say? Fit several simpler models by removing covariates and interactions from the full model. The number of models you fit is up to you. This is using the GEE function. And here I told you to use exchangeable because that's as good as any for this data set. If you choose to do other ones, that's fine, but you don't really need to here. Because what do we know about GEEs and choosing correlation structure? Do you have to be right on? No, close is good enough for choosing the correlation structure. Okay, so we can fit them in the table. And then here I've refit them with the GEE GLM command. And here I have put in waves equal month. You don't have to do that here because we have no cases where people have visits and then don't have visits and then are back for visits. It's just monitoring them, and once they fall off, they're gone. But you can't, we're not doing unstructured, so we don't have that problem with crashing R anymore. Anyone have any questions about fitting these models?
Yeah.
Yeah, question.
So this is just a question, I suppose, about research and this kind of quantitative stuff. When I saw those no initial significant values, my first thought was, okay, well, I should start messing around with different models, putting different interactions and see if I can find ones that are significant.
Yep, and that's what I did.
Okay, just to start kind of mixing stuff around and seeing like that?
There are different camps. So we have we did this model, we fit the first model with the 3-way interaction. Does sex and having diarrhea moderate the chance of having wasting disease after controlling for birth weight? That was our research question. If the answer is no, then it's like an unstated follow-up question is, if it doesn't moderate it, does it have any effect? So when we write research questions, we often write them for a specific model. But if that interaction or specific model does not yield significant results, is that the end of the story? Do you stop or do you keep poking at it? That's your question, right, Joey? And there is one camp that says, no, leave well enough alone. But by and large, the leave it alone camp is that if you keep fitting more models, you're inflating your type 1 error rate. But by and large, most people are okay with running some reduced models as long as you are transparent about what you did. So you would, if I was writing this up for publication or a dissertation, I'd say, here's the 3-way interaction model controlling for birth weight. Nothing was significant. And then be transparent and say, to follow up, we tried to fit reduced models to interpret if there's not a 3-way interaction, are there at least main effects? And this is where working in R with R Markdown, you can knit this document, include it as a supplemental or appendix, and you're transparent and reproducible and clearly not hiding that you are poking around to some degree. Now, in this case, simplifying a model is not necessarily an alternative model. It is a smaller nested model. So it's not like you're doing a totally different thing. So it's usually seen as acceptable. In this case, now I have several models here. I have the full one, and then I have several other smaller ones, more reduced nested model. No matter what I did, nothing came up as significant. Do you need all 5 of these? No, but you should have tried several, as in at least 2 competing models with not the 3-way interaction, with either lower 2-way interactions or main effects only or something. All of these we're going to use exchangeable. Now, in this situation for homework 9, we are using the same correlation structure, but different predictors or combinations of the predictors. So when we do the QIC, we want to have type R equals true to get the right type. And I put some information on here to go to read more about it. But in this case, which model is the best? It ends up being the one that has pretty much nothing in it. And that agrees with, that QIC agrees with the Wald test. So if you look at the p-values for each of the parameters, you never get any beta that's significant, no matter how you reduce it or what you add. Did anyone get anything that was significant?
Yeah,
I did.
I did.
What did you get?
The model that fit the best with mine that did have a significance was diarrhea plus month plus the birth weight, centered birth weight.
And not sex?
No.
And you got significance in some of the parameters?
Yeah. I got significant in the month. And if I do one model, I have a significant interaction. If you wanted to try this one really quick, it's kind of, it's not the best model, but it has the most significance. Sex times diarrhea plus
sex times diarrhea
plus month times the birth weight, centered birth weight.
Okay, now once we start doing this, so this is where the poking becomes maybe too much. So you should always be guided by theory. So is there any biological reasons why boy and girl babies having diarrhea has a differential effect on wasting disease? I don't know, because I don't study this stuff. I don't have a lot of background knowledge, but it should make some biological or scientific sense. If you're just simplifying it's a model, that's one thing. If you're adding all different interactions, that might not be advisable. So yeah, you are getting month by birth weight a significant interaction. Interesting. I don't see sex by diarrhea being significant. I do see month by birth weight being significant. I didn't try that one because I didn't. So let's throw it in here. Their QICs. It does win out on the QIC. What, Joey?
I think I got even a better one that's way more simple. Just diarrhea plus month plus birth weight.
Diarrhea plus month plus birth weight. I've got that one here on for model 2.
Oh, wait.
My S2.
What am I looking at?
I've got a QIC of 507 versus this one has a 502.
Oh, Oh, did you do month and diarrhea? Just month plus diarrhea?
I didn't.
Because that one was my best model, actually.
We'll look at that some more. Okay. In this one, if you didn't try some of those, so Joey's homework answers might be different than you guys's and everybody else's, and that's fine. It's totally fine. Whether or not that makes sense to do those other interactions depends on your content knowledge. And this is why you do a lit review and you're an expert in the stuff before. Like, I'm not going to go do an HIV study from the ground up because I know nothing about that, or some, so you need content expertise designing the models. But in this case, the plot I made only has month in it. And it looks pretty plain. It's just all it looks like. So the narrative, how do you write this up? If you arrived at the solution I did, is that there is a decrease in the risk and wasting over time, but that is not moderated by sex or diarrhea or anything else. Now, the way Joey did it, let's see. Let's do your 5. Model 5 had, my model 5 has, what do we put in it? Month and birth weight. So what was the range of birth weight? Where did birth weight go from? I gotta find some reasonable, what's the birth weight? Let's look at. Okay. Data long dollar birth weight divided by 100. What's the name of our data set? Is it data long? Data model. Helps to have the right name.
Sarah, may I ask a question?
Yeah, absolutely.
Did you upload a different version of this homework assignment? Because I think mine looks different from.
Did yours have the 2020 at the end of it?
Yeah. It looks like it. Homework 9 GEE skeleton 2020.
Does anyone else's not look like mine?
It's just for, I think for task 5, because when we were working on it in class together, we had this 5B, and then it asked us to use the TechReg package to create a table of the final model. Should we not have that in the assignment? Because we had issues with this too, because I think you already said that the GPAC won't let you run, or won't let you make a table with the TechReg.
Yeah.
So
I also have that on mine.
Okay, let me look up here and see if I have it.
Okay, thank you.
Yeah. Does yours look like this, Joey? Something like this?
I actually, no, I'm not to that session yet.
Okay. Yeah, okay. So did it at, let's see. Let me look at mine. So which one are we looking at, Ariel? Which one?
Oh, sorry. So I think once it starts on task 5, it says task 5B final model, tabulate the parameter estimates on our one.
Mine does look different than yours, doesn't it?
Yeah, and then it also says.
So how would we tabulate it? Tech reg, knit reg. So what are we supposed to tabulate?
Well, I read that as we're supposed to tabulate the last best model, I think, which would have been a
pretty much
GLM one.
Like that. So month is significant. Month should be significant in your model. So your final model should have month. I didn't find anything else significant because I didn't try any interactions between month and birth weight. But if you do try it, it ends up being significant. Joey found it. So Ariel, is your best model with month?
I think it is, but I couldn't get it to run in any way. But
did you use the GEE GLM one or the?
Yeah,
GEE?
it's the GPAC GLM because I.
Okay. Do you want to share your screen here? I'll stop mine.
Yeah, let me do.
Let's do that. I think that'll be more productive.
Okay.
If you guys need to go, we'll finish recording this, but I want to get this figured out. So I'll finish recording it till the end.
Okay. Can you see?
Yeah.
Okay. So this was my last test.
Now month should be in your model. Month is significant.
Oh, as one of my predictors?
Predictors. You should have month.
Okay, so just
can you scroll up before this?
Before this section?
Yeah. So go up to like I don't know which it's called. Yeah. Yeah. Even before this.
Oh.
With the one that has like the three-way interaction. This does look different than mine. Nope, down. Let's look at yeah, okay, so where's the first thing? Where's task 1? Can you go to task 1?
Okay.
Where do you get the first GEE analysis? I guess it's task 2.
Okay.
Okay. Now, so on this one, it says task 2, fit the full model. When you fit the full model, it says using exchangeable and GEE, call it fit GEE XEX full. Since the dependent variable wasting is binary, make sure you include, okay, so when you do, so what you're missing here on this first model, so everybody on this first model, it should be sex by diarrhea by month.
Okay. So no birth weight.
And birth weight goes there too. Yeah. But it should be sex diarrhea by month.
The three-way.
Oh, yeah. Hint, you might want to Grameen Center wait after it's had the units. Okay. Don't bother testing polynomial transformations of the time variable. So don't try to do month squared or month cubed, but you do need month in there.
Oh, okay. I probably read that wrong.
And I don't know if it must not have been clear enough. So if you come down here to if you look at the Z value, so this does not give you P values, but it does give you the Z value. And when is a Z value significant? When it gets close to or past 1.96. So if you look at those Z values, which one's the biggest Z value?
I think the DRH positive one.
And month is second. So when you simplify your model, you should throw out the three-way interaction and then go to two-way interactions and then maybe to main effects. But so you've got to have month in there.
Okay. So I might have to go back and.
Yeah. And my guess is since you guys all work together, you're not the only one, right?
Yeah, I didn't have month there.
Yeah, so on that very first, that's task 2A, the full model should include a three-way interaction between sex, diarrhea, and month.
Okay, thank you, Sarah. So when we get down to that 5A.
Yeah, so you've got your S4, go to your S4, it should have month in it.
Okay, sorry,
if not, it's pretty hard to plot it if it doesn't have at least one significant. So this is 3, yeah. So just for time's sake, go to your last model, your S. So in this chunk, well, let's go to the 3B because we need the GEE GLM version to plot and tabulate. So next chunk down. Yeah, so you got the full model, reducing, go down. So at the end of there, after your 4, let's make a 5th model. You can copy the model above it. That's probably going to be the fastest.
And then.
But instead of birth weight, just put in month. Yeah, just put in months there. Very good. And yeah, so that's 5. Now, if you do summary of the S5 model, yeah. Yeah, now run that one. And you should see that the month variable, if you click on the first little box there, yeah, that one. See, look, we get stars for month. It's statistically significant. So there is change in time. We know wasting, babies are more at risk at wasting earlier on versus later on. So that risk does change over time. So now when you go to the next one is to make a table. We want this S5 model. Yep, so right here, put S5, yeah. So just change it to S5 new. I think, yeah, it's just change the number 4 to 5. Yeah. Now this, oh, you've got another knit reg down there, yeah. Yeah. Okay.
So this is the one asks for the logit and the odds ratio scale, but then it's fit with the G pack.
Oh, we need to do it with the GEE package. So yeah, okay. So go back to 3A. So we need to fit it here as well. Yeah. So after 4, copy the 4. Yep. And then redo it and call it 5, but with the variable month.
Okay, so take out.
Yep, just do month. Okay, now rerun that. Yeah. Perfect. Thank you, Ariel, for being our guinea pig.
No problem. I was like, what am I doing wrong? But then I saw your note in the encyclopedia that said it's not going to work with the GPAC GLM. I just wasn't sure what I should do.
Yeah. Yeah. Now try running that one. What is it not liking? Different. Oh, instead of GLM, do GEE. Where you have it highlighted, make that GEE. There, now run it. Yay! Ariel, okay, we'll pause and let people look at this. Okay, so to do the tech reg helper to get the odds ratio, it has to be the GEE :GEE function. But when you do tech reg helper, it needs to be tech reg helper : extract GEE EXP. Yes. Yes.
Thank you. Thanks.
So now you can see now can we make the plot? Let's see if we can make a plot.
I know I'm not quite. I tried to do some of these predictions here, but I don't have the centered birth weight because I couldn't figure out.
Okay. So this is where I'll go to mine. Okay. So if you want to stop sharing yours, we got, because mine's already typed in, so I can show you. Okay. So right here, mine, it doesn't have that. Okay. So here you need, this is the way to do these. This is the best way is we need to expand grid. And I'm only going to do month. So in this model that we're going to plot, it only has one predictor, unless you're using Joey's model with birth weight. It only has one predictor, and that predictor is month. So we want to make predictions over the months 0 to 8. So you don't even have to do expand grid, but I'm in the habit. So we need to have the months 0 through 8 in a data set. And then to that, we're going to add a prediction based on that model. And I did type equals response, and that gives us the probability of wasting for each of those months. Now, the name of your model might be different than mine. To do the table, we needed the GEE package, but to do the plotting and the predictions, we have to use the GEE GLM package. Now, if you're doing Joey's with more than one variable, my expand grid has, in addition to having months 0 through 8, I have to choose some values for birth weight. And that's why I did a summary step to see what were my birth weights. And this birth weight 100 variable, the smallest baby was 10, the biggest baby was 47. So I chose some values that were in the middle range, 20, 30, 40. You can choose different values. These are just illustrative only. So as long as they're within the range that you observed. So now on this one, so Ariel's with just the month, we have only months. So we're going to make predictions over those months 0 through 8. Ariel, were you able to get that much?
Yeah.
Okay. And now when we plot it, our X variable is going to be month and our Y value is going to be this fitted or predicted probability of wasting. And I've just connected, we're doing the whole thing now. And then just, I made a line and you just see one line. So we can see initially, this is our risk of wasting. And then as the baby gets older, that risk declines. And we did not see it being different based on if they had diarrhea or they're boys or girls or both of those things. Now, what Joey was able to find was it does depend on birth weight. So that model, when I do the expand grid, the nice thing about expand grid is I have the variable month, which I want to go 0 to 8, but I also have birth weight, which I'm going to pick 20, 30, and 40. And the expand grid does all possible combinations of months 0 through 8 and birth weights 20, 30, 40 is what I've chosen. So you can see for birth weights of 20, I've got months through 1 through 8, 0 through 8, and then it starts over with months 0 through 8 for now weight 30. And if we scroll down further, it goes to 40 because those are the numbers I put in. So I can make predictions for all of those combinations. Now month, I want to be my x-axis, but I want a different line for each of these birth weights I picked out. And because birth weight, to make lines by birth weight, I need this birth weight variable to be a factor so I can make lines by it. So I had to add in a step where I took the birth weight and made it a factor version of itself because I'm only plotting these 3 specific values of birth weight, 20, 30, 40. And that, when I plot it that way, so that's the things that I've added here from the other one is I added birth weight. My model has month and birth weight both in it. And then birth weight, I had to make a factor version of itself so that I could make different lines, different colors based on which birth weight the baby was. So here we get what's this red line up here are light babies, 20, but it's actually 20 times 100, so they're 2,000 times 100. 20 times 100. Anyway, what's 20 times 100? My brain's done. Is your brain done? 20. 2,000. I was right. So a 2,000 gram baby, this is their risk line in red. And then a 3,000 gram baby, that's in green. And then a 4,000 gram baby, that's their line in blue. So the heavier the baby, the lower risk, not just to start out with, but this red line is kind of straight. This blue line goes down really fast. So if a baby's heavier, their initial risk is lower, but then their risk more drastically depreciates or goes down as they get older. That help answer homework questions for homework 9. Other questions for homework 9? No, Mike, we're good? Alex? Yeah, Julie?
Can you scroll up to the final model that just had month as significant? For some reason, I'm getting like a weird error and I just want
to fit with the GEE?
Yeah.
Or the GEE pack?
The GEE.
GEE. Right here.
Okay. Thank you. I don't know. Okay.
Does yours look the same?
Yeah, but
it's still
I'll figure it out. just staring at things for too long. So I'll
You
figure
want
it
to
out. I
share
just
your
took a picture.
screen?
No, it's okay. I actually have to go, but I just wanted to make sure before I went. Thanks.
Okay.
Sarah, sorry, I think I may have had the same code as you, but I am getting an error for the plot you just ran. The second to the, you have time.
Yeah, I have time. Why don't you share your screen? And I'm going to leave the recording going if you're okay with that. Because you're probably not the only one with this issue.
Okay.
And I'm going to set up an office hour too.
Okay, thank you. That's totally fine. So let's see. I'm sharing and it should be here. Okay. I lost my spot. I think I'm
easy to do. Okay.
Okay. And I typed it all by hand, so I might have something wrong here.
Okay. So why don't we highlight little bits? So start on line. This is how I troubleshoot. So start on line 748 and highlight until you stop before the pipe. Okay. Line 748. Or yeah, do that. That's fine. All the way to the top. Yeah. Let's see if it gets.
There.
So let's see. Okay, so highlight. So the model doesn't have birth weight, or does have birth weight in it. Okay, so highlight just the name of the model, fit GEE-EXP-S, yeah, where your mouse is, right. Highlight just the name of that model and do the control enter to run just that model. Now let's scroll down and look at that model. So this model has, this model has wasting and birth weight both in the model. So to make predictions, you need to have both wasting and birth weight to predict over. So you go to your expand grid, after it says month equals 0 to 8, you need to do comma enter.
Okay.
And then enter birth weight equals, and that's funky spelling, equals, and then C to concatenate, open parentheses, and you can do 20, 30, 40 with commas between them. And I looked at the data to make sure that's the range. Now try it.
So this whole.
Now this is not going to work because just do the prediction part. Oh, it's birth weight 100. Sorry, it's birth weight 100 on line 749.
Oh, okay. And then try it from here again.
Yes. Okay, scroll down. Let's see what this error message says. Problem with mutate. Okay, let's look at the mutate again. So scroll back up. Dplayer, mutate, fit equals predict, new data equals dot, type equals response. Let me look at mine for a second. Fit equals predict. Something like that. Do just the expand grid. Let's look at that. Like expand grid and then it's parentheses.
Okay, so
to the end of the next line. Yes, that's what I was thinking. Okay, so that made the grid. Highlight the name of the model again. I think we might have the spelling of birth weight wrong.
Okay.
So on the next line down, the name of the model, run that. Okay, scroll down, highlight birth weight 100. Yeah, copy that and paste it there. Now try to see if you can get the predictions. That should work, but now in the next chunk. Yeah. Still not. Let's see. Scroll up to yours and I'm going to put mine here and I'm going to see if we can find, there's got to be just a typo somewhere.
Oh, is it because I have the centered birth weight?
Nope, that shouldn't be a problem because it's internally centered.
Oh, okay.
Fit equals predict fit. Oh, it's got to be the GEE GLM version.
Oh, okay. So this isn't the right. This is probably not the right model then.
Yeah, it needs to be the GLM. Yeah, the new. Yeah, now try it. Now that's not going to work. Well, it will. It's just going to look funky.
Oh.
Because birth weight is not be in your plot. So go to the, so do just the prediction before the GEE plot. So nope, the next step 2.
Okay.
Yeah. So for each month, for each of those weights, we have a predicted probability, but birth weight we need to make that a factor first. So that's the intermediate step we need to do.
Okay.
Right there, they're both numbers, an integer and a DBL number value. So go back into your code, and after the highlighted part, but before the GG plot, add a step in there. Do dplyr double colon mutate open parentheses that birth weight 100 variable name equals factor, and then open parentheses and do the birth weight 100. And then at the end, do a pipe. And then go down 2 lines, and after y equals fit, after the y equals fit, before the close parentheses,
right.
yes, comma, enter, color equals birth weight 100.
WG, okay.
Now run it. That doesn't look right. Does that model not have month in it?
Let me check.
We want the model that has month and birth weight.
That's not the right one. I should probably, the one that you just helped me make, that's probably the one I need, right?
Let's go to the GEE GLM chunk. That's 3B or 3A, yeah.
Okay.
Yeah.
So I think
we want one that has month. That one has month 5. Oh, we want the one with GEE GLM, the GEE pack. Yeah. We want a model that has birth weight. That has month. We want the one, maybe look above it. Does the one above it have? Oh, see, we need to add month in that one. We want a model that has both birth weight and month in it.
so. Month.
So that's the problem. You had one that had month and you have one that has birth weight, but we need a model that has both month and birth weight. Yeah, run that one.
Does that look right?
Yeah.
Okay, month plus
birth weight. Now your plot should work.
Okay, so that's down
5.
here.
Yeah.
And just gotta change this guy, which it should be. I actually forgot what it's called, but I copied it. Oh, it didn't.
No, it didn't copy.
I'm sorry.
No, that's fine.
I can't.
5 new or 4 new?
I might have to recheck again.
I think it's 4A.
Oh, so sorry. 4A.
4A.
Here we go. So this is it. S4 new.
4 new. There we go. Month and birth weight. Yep, that's the chunk, but all the way down at the bottom.
Oh, right. Okay, I was like.
Yeah. There. Line 750.
750. Thank you.
Yeah, right there where it says fit.
Fit. Okay. Just got lost there.
Yeah.
Okay. And then we should be. Oh, awesome.
Yay.
Thank you. Okay.
So the lighter baby is the red, the heavier baby is the blue.
So this is, okay, like 4,000 grams.
3,000 grams and 2,000 grams.
Okay. So the probability of wasting is higher for
lighter babies.
Birth weights.
And the risk is higher right after birth, and that risk decreases as the baby gets older.
Okay. Awesome. Thank you, Sarah. I'm sorry to keep you.
No, it's great. This is exactly, and everyone in class is going to be glad that you did that, because then they can watch it.
Okay. Thank you so much.
Okay. We'll see you later. I will put a thing about office hours up.
Okay, awesome.
Okay. Bye.